Welcome, everybody. My name's Jennifer Griffith. I work at the Northeast Waste Management Officials Association, otherwise known as NUMOA. Kathy, are you seeing the NUMOA website on your screen?
Yes, I am.
You are. Great. So I have this up here for two reasons. One is so that folks can read for yourselves about NUMOA. We're an interstate association. The 6 New England states, New York and New Jersey, work together, the waste programs, which include the waste site cleanup programs. And so one of the major priorities for the waste site cleanup programs through NUMOA is training for their state staff. But also we often decide that it's great for everybody to be on the same page and learn the same information. So we open up our trainings to everybody, including the consulting community and anyone else. And so that's what we're doing here today. Another priority for the states since about 2016 has been Pfas. So today we're combining both of those, training and information sharing, and then also about Pfas for this webinar today. So this is the final webinar in the series that we've been holding this spring. So the other reason to show you the NUMOA website is to show you where afterwards the presentations from today will be posted, as well as where you can find presentations from prior webinars. So you go to the NUMOA website, which is just numoa.org. You pick waste site cleanup, and the website is going to be slow. Oh, that's not good. Well, anyway, you pick waste site cleanup, then you pick events, and then when you get to events, there's a whole long list of the different NUMOA events. The ones out the farthest in the future are at the top, and then it goes, chronologically from the future into the past. And you'll be able to scroll down. We hold events for, let me just see if I can start a different website connection here. No, it is just going to be slow. All right, well, with that, I will switch the presenter over, and we can maybe show you at the end. To our first presenter today is going to be, before that, there's too many people on the webinar today to be able to have people ask questions verbally, so you will have to type them in your control panel. There is a section of questions, and you can type questions in at any point. I will be monitoring the questions, and when the presentation is over, I will ask questions that have come in. And we'll get through as many as we can, and then we'll have the second presentation, and then we'll do questions again at the end. So I think that's good enough for logistics. So our first presenter is Catherine Beam. She's an administrator at the New Hampshire Department of Environmental Services in the Air Resources Division. She's been actively collaborating since 2016 with organizations around the country on air-related PFAS issues. Her primary focus in New Hampshire has been permitting the installation of a regenerative thermal oxidizer for PFAS emission controls, identifying potential PFAS emission sources, sampling various media, stack testing air emission sources for PFAS, and deposition modeling of historical and current PFAS emissions from industrial facilities. So a lot of things, PFAS and air emissions. During her nearly 20 years with the Department of Environmental Services, she's been responsible for rulemaking and state implementation plans, air permitting of industrial sources, outreach regarding state and federal regs, lots and lots of stuff. She's got her Bachelor of Science degree in Chemical Engineering from the University of Maine. So with that, Kathy's going to tell us what's going on in New Hampshire. Take it away.
Thank you, Jennifer. So as Jennifer mentioned, I've been working on this PFAS issue here in New Hampshire since 2016. Our facility actually has been in operation since the mid-'80s here in the state. And I know primarily the focus of PFAS has been in groundwater and drinking water and biosolids and all of those type of areas. What I'd like to talk about today is just the air component of where PFAS emissions might impact, especially in states around the country that maybe are just getting up to speed on all of this. So the primary pathway that we've been dealing with this particular facility is through their air emissions, but we do have PFAS sites throughout the state that are not air sites, landfills and other types of Air Force bases and stuff like that. But today I'm going to be talking about a manufacturing facility and kind of the history that we've gone through with that. Let's see if I can get this to advance. There we go. But to start us off, I just kind of wanted to give you a brief overview of where PFAS might be found in air emissions, just to get everyone up to speed. You may have heard of some of the issues that were surrounding West Virginia and North Carolina and even out in Minnesota, where the manufacturing facilities that make these raw materials had releases to the atmosphere as well as localized emissions or releases. Those particular facilities have, much larger levels of emissions than perhaps the industrial facility that I'm dealing with, but they manufacture the raw materials that come to our facilities. And so a lot of the studies that have been around those locations have been used to get a better understanding at these other sites. So our particular industrial facility is a coating facility. They apply a PTFE coating to fabric to make various products, but that is not an exclusive industry that would have these issues. There's also manufacturers of medical tubing or coating of wires and other types of operations where they may use, and in this case, a liquid dispersion that applies these compounds or forms those products. And the heating of those has caused emissions from the stacks. And then in addition to using the product to make a final commercial product, there's also the use of PFAS compounds as mist suppressants. In this case, I'm showing an example of chrome platers who are not making a product that has PFAS in it, but who historically used a PFOS containing mist suppressant to keep the hexavalent chromium from exposing the occupation, the workers in the facility to that compound. But unfortunately, using that has then resulted in either being emitted, if they evaporated some of the waste material that they had there, or if they had other types of exhausts related to the chrome plater, having a release of that PFOS at that facility. And then, of course, talking about PFAS, you can't not talk about landfills, wastewater treatment plants, and airports and Department of Defense sites, primarily talking about the leachate that comes from the landfills or the biosolids maybe that come from the wastewater treatment plant. But in terms of air emissions, I wanted to kind of bring to everyone's attention that there has been some studies done in terms of upwind and downwind of landfills and treatment plants, looking at ambient levels of PFAS, mostly in the picogram level, much lower than the stack test emissions of the facilities, but still detectable around these locations as dust or as vapors. There's also studies that's being conducted through a grant from EPA to look at whether PFAS compounds exist in landfill gas, most likely the shorter chain or more volatile compounds, the telomer alcohols, that sort of thing. And then with the biosolids from the wastewater treatment plants, there's been a lot of discussion, I suppose, on land application, but there's also the possibility that those biosolids could be returned to a landfill for disposal or incinerated in a sewage sludge incinerator. And there's been some curiosity and some work done to look at possible emission sources of sewage sludge incinerators as well. And then finally, just talking about using AFFF at airports and DoD sites and the possibility of the foam contaminating and blowing away and contaminating the area around that as well. So just some areas where PFAS might be found as a result of air emissions, not necessarily direct release through liquid or solids. So to put everyone on kind of the same playing field with the type of facility I'm been primarily working with, I just wanted to go over a typical, fabric coater that uses these compounds. In our particular case, as I said, they would purchase raw materials, and those raw materials have the compounds that they want to apply to the fabric, whether it be PTFE or other polymers. But in order to keep those in suspension in the coatings, they needed to have some sort of a surfactant or a dispersion material that would keep those compounds, like I said, in solution. And so they would purchase, in the past, these raw materials that would contain percent levels of PFOA or the ammonia salt of PFOA in those raw materials. They would mix those compounds to make the coatings that they would then put into a dip pan, and the fabric would then be rolled through the dip pan and up vertically into these 3-section towers. And the towers would then dry the fabric to first remove the water, so bringing it up to over 100 degrees C, then up through to the second stage where they would volatilize off that surfactant that was used in the coating. And then finally, in our case, sintering the resin onto the fabric to make the product that they were selling to their customers. Of course, all 3 of those vents would then combine into a single vent to the atmosphere, and that's where a lot of our stack testing has occurred, is at that point. So just to give you a little bit of history of our facility, it started operation in the mid-'80s as one company. They had, as you can see, the steps going up over time is really reflective of the number of towers that they had at the facility. And it wasn't until 2004 that they actually conducted some stack testing. And a lot of the history of this facility I now know as a result of doing a lot of research. At the time, they contacted us to let us know they were testing the facility, that the emissions from that facility of this ammonia salt of PFOA was at a certain level that at that level would cause a violation of our State Air Toxics Control Act, which was in place as of the 1980s. So we actually had a standard for air inhalation of the ammonia perfluorooctanoic material, the ammonia salt of PFOA, on the books. And it was as a result of that standard and that stack test that the facility entered into a consent decree to reformulate. Looking back over time, it's clear that that stack test was done as part of a dispersion study that the manufacturers were looking to conduct for research for EPA for their own reformulation issues. And the reformulation was also at the same time being done by the manufacturers. So all of this took place in and around 2004 to 2006. And by the end of 2007, they had reduced the SAFFO concentration in their raw materials by over 96%. So at that point, it no longer became an inhalation issue, and they continued to operate at these much lower APFO levels. It wasn't until they tested the water supply coming in from the public water system in 2016 that they notified the department that they had elevated levels of PFOA in the water. And of course, knowing the history of the emissions from the facility and the extent to which we later found the contamination around the facility, including across the river and up gradient of any groundwater flow patterns, it was clear that it was an air emission source of this contamination. So I wanted to point out to you in this chart, this is specifically looking at PFOA stack test emissions in 2004 and applying it based on the number of towers. This isn't looking at any other PFAS compounds that we would now be looking at in 2021, or precursors or any products of incomplete combustion. This was simply trying to identify where PFOA was going at that time. So we took those results, and because of the water contamination issue, we wanted to be able to make sure that the department and the public knew where this impact had occurred so that they could test wells and protect the public. Also to help inform the site investigation team and determine just how large an area this air emission source had impacted. And as you can see, it initially impacted, based on our ambient groundwater quality standards, an area of about 64 square miles of New Hampshire area, including 4 surrounding towns. And So we have been working as a department with the facility to get public water systems to these homeowners that had high levels and dealing with the contamination issue. But this modeling was really used to help decide where that area was. So in the meantime, they had complied with the ambient air standard. They'd reformulated, and they were dealing with the water contamination issue, but we did not have on the books any kind of standard that required air emissions that cause or contribute to a groundwater problem. There were no regulations at that time. So between 2016 and 2018, the Air Division continued to work with the company to test the raw materials coming in, the coatings that were being applied, dust that was collected outside the windowsills at a condominium across the street. Their consultant did some wipe samples on the roof. There was significant amount of char buildup in the stacks and residue that was either a sticky material or a dry, crusty material that was flaking off onto the roof. That was all sampled, and then there was 3 or 4 different stack tests. It's 4 stack tests, 3 in 2016 and 1 in 2018, to look at what kind of PFAS emissions were coming from the facility. So all of that information, along with that historical emissions and modeling, was used to kind of evaluate the facility and its impacts and its contribution to the issues. So I just wanted to kind of go over some of the observations we made during the 2016 and 2018 stack tests. In 2016, the department contracted with a stack testing company to go out and collect information of the emissions from the facility. There were several PFAS compounds that were emitted and were measured at low levels. And keep in mind, there are no EPA certified standard methods for PFAS testing, especially in 2016. The testing that was done in 2004 timeframe was a method developed by the company's stack testing company that they had recruited. And that was the same method that was used in 2016. Detection levels were getting better at that point to be able to detect these compounds, and these were 3 of the emissions that were detected in 2016. The company then worked with their own stack testing company to come in and confirm what we had found, and they did some various tests. So they ran some stack tests when they were not putting coating on the fabric, and they still found emissions. They cleaned out the tower that we were stack testing. They cleaned out the ovens. They replaced the ductwork, the stack, and the dilution fan, and they found that they reduced PFOA emissions by 67% just by doing basic housekeeping, but still emissions coming from the facility in 2016. In 2018, we had the opportunity to work with EPA's Office of Research and Development, and they were willing to do some non-targeted analysis of the samples that we would get from a stack test. So we, again, worked with a company. They hired a stack testing company to come out and conduct sampling. We doubled the number of samples that we took so that we could send half of them to the Office of Research and Development. And ORD worked with the stack testing company to do some methods development. So they added some XAD traps, and they expanded sort of the sampling train, as well as adding summa canisters to sample for some of the compounds that you wouldn't have necessarily gotten from the sample train. And I will defer to Wesley on the specifics of the sampling methodology, but a lot of the 2018 stack test was to help ORD develop a method for stack testing that they could use in the future. And the company itself had brought in a pilot scale pollution control device that they wanted to test to see if it would be effective for the emissions of PFAS. And they found that from their commercial lab results that it wasn't effective for all PFAS compounds. And then EPA reported back to the department the information that they had obtained from evaluating the filters and the XAD trap. And they found that about 190 different PFAS compounds that were detected, and they could only identify about 89 of those in some fraction of the sample train. And they found 12 PFAS in the summa canisters. So there was what I believe to be some products of incomplete combustion, some breakdown products that were coming out of the stack as a result of the heat of the tower, but without controls, it wasn't completely being destroyed. So yes, maybe PFOA was much lower, or any of the other compounds were much lower, but they weren't exactly being destroyed, simply being transformed. And but the PFOA emission levels were still high enough at that point to trigger what I deem the New Hampshire back law, which was a law that came into effect in 2018. And I won't read it to you, but it basically says that if you've contributed to a violation and you're continuing to contribute to it, you need contribute to an ambient groundwater or surface water quality standard violation. Then you have to put an evaluation of your emissions and determine what would be best available control technology, and then apply for permit to operate that. In addition, once that control is put on, the emissions can't continue to cause or contribute to a violation. So in 2019, they applied for the installation of a 3-chamber regenerative thermal oxidizer. And in February of 2020, the department issued a permit with operating conditions for how that RTO should operate, and determined that that was the best available control technology. Now, as many of you are probably familiar with, incineration of PFAS is still an evolving science, and more information is always coming in and necessary to make good determinations. The operating parameters for which this RTO has been required to be designed based on the permit was based on an August 2019 EPA technical brief, in which they stated that to get 99.99% destruction of fluorinated compounds, you'd need to be above 1,000 degrees C for a second of residence time. So that's what's required of this particular RTO. And the intent is, although we have standards, groundwater standards for 4 PFAS compounds, an RTO should destroy all of the PFAS compounds, or at least degrade them. So the concern, of course, is if there's products of incomplete combustion, and then of course hydrogen fluoride would be formed through the combustion of PFAS compounds. So where does New Hampshire go from here? The thermal oxidizer was supposed to be installed in February. The company did not meet that deadline. They are under a consent decree to have it in by the end of July of this year. We are currently evaluating some information that they were required to gather on PFAS content in their raw materials, and reviewing a material balance and making sure that the hydrogen fluoride emissions don't exceed the standards in our state air toxics rule. We're also preparing for the RTO stack test. The company, as well as the department, are conducting a rainwater study similar to what other states have been doing, to look at what level of PFAS is just basically coming down at background levels. And then we're continuing to work with EPA, maybe not so much on methods development, but on validation. They have come out with OTM 45, which I'm sure Wes will cover, that will be one of the stack test methods that we will use during the test. But then there's other destruction efficiency test method. I don't think it has an official name, but they would propose using a surrogate to try to determine the destruction efficiency of the RTO. And then we're further investigating other stack test information that we have, and looking at our own facilities and reviewing national information about stack test and emissions. And finally, we're going to be reviewing the TRI data next year and determining if there's any other sites that we should be concerned about. With that, I can open up to questions.
Wow, great. We're ahead of schedule here too. So that was super interesting, Kathy. There's one question so far, but folks can type in any that they have. Is there information whether PFAS is volatilizing, or is it being carried on droplets or particles through the air?
Excellent question. The answer is both. I'm not an expert on stack testing, but I believe that the filters are designed to collect the particles, the impingers, the gases, and then the reason that they had Insuma canisters there is because PFAS, can be either polar or non-polar, volatile, semi-volatile. So there's a lot of different ways that the PFAS can present themselves, and stack testing has to be able to account for all of that. But I often hear from EPA is if you don't look for it, you won't find it, because there's a lot of variability in PFAS. But yes, they would come out both as a particle and as a vapor, and that's how, when we did the deposition modeling, we looked at it in both ways. So.
Okay. How about, do you know what kind of disposal were they able to do with the duct work and all that stuff? And are there concerns about that, that physical stuff that they removed and the cleaning process, I guess, and the residuals from that?
Yeah. I don't remember off the top of my head, but I know that they worked, I believe, with a hazardous waste landfill, possibly. I know that they had companies that came in to do the work. Unfortunately, there's not a whole lot of regulation around that particular aspect, so I was not completely involved in supervising or regulating the disposal, but I know that they had the equipment on site and they were disposing of it through I want to say a hazardous waste landfill, but don't quote me on that. I'd have to look into that.
Okay. Going back to the original question and just follow up from that, is there any sense about which transport form is dominant, the volatilization, the droplets, the particles?
I don't know if I can answer that. The 2018 stack test was a methods development, and the report we got back from EPA was all related to the filters. So yeah, I don't really know how much would have been in the impingers and how much that ratio would have looked like. But I believe the next round of stack testing, which will take place in September of this year, will probably be one of the most comprehensive stack tests I've ever been involved with. Not only looking at PFAS, but air toxics and destruction efficiency and methods that haven't been used in the state before. So we should be getting a lot more information after that point.
Okay. Are there thoughts of having the company use a scrubber for the hydrogen fluoride?
Yes. So the evaluation thus far, both with the stack test results and now we're looking at the raw material results and haven't made a final determination on that. But both ways indicate that the emissions of hydrogen fluoride are below our air toxics limits. If it was above the toxics limits, then they would be required to do something, whether it be cut back on operations or put on a scrubber or whatever would require to meet those standards. They're ambient standards for both 24-hour and annual timeframes. So yes, typically I would say that an RTO in this situation would have a scrubber, certainly at a larger manufacturing facility that makes these products. These emissions are quite low and measuring them is quite difficult in the first place, let alone quantifying the HF. So thus far, there has not been a regulatory requirement to put on a scrubber, but we're evaluating that.
Okay. So getting back to the low levels, is there a lower detection limit for PFOA using a stack test method? What's the detection limit?
I think I'm going to defer to Wesley when he talks about his methods, because I think it all depends on a lot of the laboratory analytical capabilities and the length of time of the stack test, sampling levels and that sort of thing.
All right, yeah, we're going to get in a lot more on the logistics of stack testing and analysis with the next presentation. So let's see, you had 2016 and 2018 stack testing. Was there any change in operation of the facility there, or only a difference in the test methods?
Only a difference in the test methods. They pretty much have been making the same products and the same raw materials throughout the whole period.
Okay. All right. Well, let's see. How much hydrogen fluoride is created through the oxidizer? I forget. Did you just mention that or not?
I don't have that number specifically off the top of my head right now. I can look it up, but in the essence of time, I don't really know off the top of my head. I think it was very low, though.
Okay. Okay, so this is another one for Wesley, maybe a little more, but although maybe he's biased because he was involved with developing it. How confident are you in EPA's proposed stack testing method?
Again, I'm not a stack test expert. I believe it came a lot from both I think it got developed mostly from both, the testing that had been done in 2004 was developed by a stack testing company. It was sort of the emphasis for the start of the 2016 testing. EPA added a few extra things to it to 2018. So I think it's grown over time, but it's generally the same method. There's another method that they've been using in North Carolina that I think Wes is going to cover that has extensively been studied, because I think they tested every week for a year. So they would defer to him on that one. Yeah, I looked up the emission rates for the previous question. When we got our report from EPA ORD, we didn't get quantitative analysis. It was just qualitative. So we did some calculations ourselves, and we estimated that the pounds per hour were 0.24 pounds an hour. So again, very, very low emission rates when it comes to the ambient air standards that we have in the state.
That's for the hydrogen fluoride?
Yes. Yeah.
Okay. All right. Do you know if the facility tried doing anything about its drying process and changing the temperature, that they were using to try to lower emissions that way, or any?
Well, so there's a certain product qualification that, they want to make a certain product, and it has to, in order to get to the sintering level, you have to get to a certain temperature. So I think that's sort of dependent on the product they're making, and not really on I don't think they made much for changes there. You have to get to a certain temperature to drive off the water, and then get to another higher temperature to sinter the product. So I don't think there's a lot of flexibility in that area.
Okay, are all of the stack tests and results and other things and the protocol, the new protocol they're going to be using, is that available on the New Hampshire DES website anywhere?
The stack test results are all on our one-stop page. I'm not sure if the protocol is part of that, but I'm pretty sure if it's not within the stack test section, it's within the correspondence section, but all on our one-stop page, which I can certainly help someone if they're looking to try to find that.
Yeah, or you might just be able to Google New Hampshire DES one stop, and that might get you there. It's sort of a data portal. There's all kinds of stuff up there for all kinds of different facilities. So sometimes it can take a little while to figure out where to go in there and find what you're looking for. But okay, how about, so I don't think it's a secret who this company is, which is a huge multinational company. So maybe the added costs aren't that much for a big, huge corporation like that. But how about if this was a smaller, local company? What's the added cost of all this? Or do you know? Is it a lot?
There was a similar company that spun off from this one that was a smaller company and argued that it was extremely expensive. I don't have the numbers off the top of my head. I want to say it was around the $50,000 mark for stack testing. But that didn't factor into our requirement to make them test as well. So perhaps I should be looking at prices, but sometimes that's secondary. No, I don't know the numbers off the top of my head.
Right. Regarding future efforts and other, efforts to look for other sources potentially, someone's pointing out that the TRI reporting limits for PFAS are pretty high, like 1%. So you might not have that much reporting going on.
Yeah, I recognize that. That was one of our comments as well. New Hampshire has done an extensive amount of groundwater testing, and that, combined with our industrial knowledge of the facilities here in the state and some of the other information that we have, has been able to help us pinpoint some of the other locations where I might be able to do further investigation. But for the most part, I think from an air source, we have a general idea of where our concerns are. And those two facilities and a couple others are, rest of them are probably, like I said, the chrome platers. We had a chrome plater, but they're no longer using that PFOS mist suppressant, and it was an evaporator that I don't believe is being operated anymore. So a lot of them are much smaller or not in operation anymore.
Okay, so you kind of answered my next question, which would be, the magnitude of the issue. It sounds like it's not huge and overwhelming, the potential from this media, the air impacts to groundwater. It's definitely a problem, but it's not expected to be an overwhelming problem.
New Hampshire's a small state. But yeah, from the number of air sources, small. The impact area, the largest in the state. So, depends on how you want to frame how big an issue it is.
Yeah. Okay, here's one last question, and then I think we'll move on to the next presentation. Was a background evaluation done within this air dispersion impact area or potential that you modeled to determine if all of the PFAS was attributable to the emission source, or if you did, what percent of the impact was from that specific site versus potential other sources?
We've looked at it as a sole air source, and I haven't parsed off a percentage that wouldn't be contributed from them. So,
I mean, I think we do know there's some just background level in air, period, correct?
Well, that's why we're doing the rainwater study, and why the company is looking at rainwater on property and then at 2 other locations to try to get some idea of what background levels we have in the state. But that's moving forward. That isn't related to this evaluation and this permitting process at this point.
Okay. And the results are not available yet. So, all right. Well, I think that covers the questions that have come in, which were quite a few. So thank you again, Kathy. And now we'll turn it over to our next presenter, who is, hang on a second here, Wesley Fritz. He is a client account manager with Weston Solutions and in their integrated air services group. He has 29 years of professional experience managing, leading, and performing stack test sampling projects. Wes has performed emissions testing for a wide variety of industrial clients using including chemical manufacturing, petrochemical refineries, power generation, manufacturing, and pharmaceuticals. He's led programs focused on developing stack testing methods to measure isocyanates and PFAS in point source emissions. He's got his Bachelor of Science in Physics from Westchester University. So with that, take it over, Wes.
Hello, everybody. Can you hear me and see my screen?
Yes, both. Yes to both. We are all set.
Okay, good deal. All right. Well, thank you, Jennifer, and thank you everybody that's on here to listen. I appreciate the opportunity here. So, like Jennifer said, I'm with Weston Solutions. Weston's an environmental consulting firm, and we have about 1,000 people and 25 offices across the country, and we do emissions testing out of 3 of those offices: Houston, Auburn, Alabama, and I'm in just outside of Philadelphia in Westchester, Pennsylvania. So, the title is Innovative Sampling Analysis Techniques for Stack Testing and Air Emission Sources. So, actually, Kathy touched on some of this, and I was glad to see her presentation. We actually did some of the testing in that 2016 study at that facility. So it was good to see that data is still being used. Let me just go on here. All right. So, what are we talking about here for PFAS and air emissions testing? As Kathy said, the focus has been on drinking water, groundwater, soil, and not that much focus on air to date, but that is changing. We're starting to see this come up in numerous states and numerous facilities. there's no validated ambient air monitoring methods for PFAS, and there's very few regulatory standards for PFAS in air. So this is, we're on the very genesis of this. My slide used to say that there were no validated stack testing methods for PFAS, but in January of this year, EPA came out with their draft, what they're calling other test method, OTM 45, for measuring PFAS in stack emissions. So that's kind of where we're at. That's the backdrop of it. And, you know, this is my chance to tell our story here. So why air? So in sometime in 2016 or 2017, they found PFAS in the drinking water in Wilmington, North Carolina. And it didn't take them too long to look around and say, okay, well, there's a facility about 40 miles upstream that makes these materials, and started doing some investigation. That was at the Chemours facility in Fayetteville, North Carolina. They started looking at it. They started doing groundwater testing at different, around that facility, and they found PFAS in the groundwater, in the wells, water that they were sampling. And they just noticed, okay, we're seeing, contamination in wells that are, upstream of the plant. So how is that happening? And this is all along the Cape Fear River in North Carolina. They immediately went to, okay, air emissions, and they started doing some modeling, and they found that, yeah, where they're seeing the concentrations, fit the air dispersion modeling. So, court orders and investigations and all that happened, and Chemours was put in the position of cleaning up a lot of things at the plant, but one of the things that they had to do was start cleaning up the air emissions. And they called on us to do some stack testing, and they called on Test America to work with us on the analytical side of it. So, as Kathy mentioned, there were some stack testing methods out there that were being used. When we got involved, Test America, we started looking at this, and we kind of wanted to do something a little different than what was already out there. And we ended up looking at it's an SW846 test method 0010. This is a semi-volatile organic compound testing method. And we start, it's a tried and true method. That method has been out there. It's a method that we use on hazardous waste incineration trial burns, and it's been out there for a long time. So as long as I've been around this, so we made some modifications to it, changed some of the recovery solvents, changed a little bit of the components in the sampling train, and that's what we went with. And so for 2 years, 2018, 2019, we were down there doing testing, a lot of testing, using that method and another method I'll discuss. That method really is what was kind of adopted by EPA as their draft OTM 45 method with a few changes. So, some of the things we had to look at in getting to this were, okay, what are we even looking for? Because there's no background for air. I mean, all this, everything that's happened up to then had been mainly in drinking water. And so we have these methods out there, 537, 533, this EPA method 8327. I'm not that familiar with, but I included it in here because it's noted in the actual EPA draft OTM 45 method. So you see there, right, 18 compounds in 537, 25 compounds in 533, 24 in this 8327. And if you look at OTM 45, there's about 50 compounds listed as the analytes that are targeted. So, and I put approximately on there because that list, I think, is evolving, and it can evolve if we have the right standards and all to to set up for the analysis. But with over 6,000 PFAS compounds, I've seen that number anywhere from 4,000 to 9,000 to whatever. But we're only targeting a small number of these compounds, and most of these fit in the semi-volatile range, and that was where we decided to go with the EPA SWA 46 method 0010, because that's the range that we were looking at, and that's where these compounds fell into. So just a little bit about this. Here are some of the common compounds that we're looking for, these PFAS substances, and we see the 8-chain or 7-chain tail with the head of different compounds can be associated with this carbon chain. And these are the two standbys that everybody's looking at, or has looked at in the past, is these PFOA, PFAS. And then I included one of these fluorotelmers in this just to kind of make the point that the PFOA and the PFAS, they fall under per, because every carbon on here is attached to some fluoride, and then that head is the last piece of it, is where we see these different types of PFAS compounds, for lack of a better word here. But these fluorotelmers are precursors. So this can drop out. These carbon and hydrogen can fall off this thing, or be driven off this, and then it falls back into one of these, the PFOA or the PFAS. It can change. So these are the precursors for these PFAS compounds that are listed in there. And so some of these fluorotelmer alcohols or sulfonates are included in OTM 45 in the analytical breakdown. So just throwing that out there, because actually I'm going to come back to some of these fluorotelmers a little while later, these precursors. So where we're at, this is a schematic of draft EPA method OTM 45. And hopefully you can see my cursor here, because I'm going to walk through this a little bit. The sample is collected isokinetically, and that means that we're pulling the gas sample into our sampling system at the same velocity that the gas is moving through the stack. And the reason we do that, and this is kind of touch on one of the questions from the previous presentation, is the PFAS can be in particulate form, or it can be agglomerated or attached to particulate that is moving through the stack. And so to do this, where we're capturing the right amount of particulate matter for the amount of gas going up through the stack, we do this in what is termed isokinetically. So it's an isokinetic stack sampling method. The gas is captured, goes through a heated probe, and then to a filter. This is either a glass fiber or a quartz fiber filter. This probe is heated to either the stack temperature or just above the stack temperature. If the stack temperature is above 248 degrees Fahrenheit, then we heat it to 248 plus or minus 25. Gas goes through the system, and here we have a condensing coil. So this is a water jacketed coil. It's all glass, and you see over here there's a pump. We're pumping ice water that is in this system through this around this coil to cool this gas down. So if it's 250 degrees coming out of here, we're going to cool it down to 68 degrees and condense as much as we can out of this. The next phase of this is a resin trap, and it's labeled XAD resin or XAD2 resin. So gas passing through here, these PFAS compounds are in this semi-volatile range. They're captured in this absorbing resin in this trap. Goes down into a set of impingers. Get this cursor right. First impinger is just a knockout. So this is just any condensate that's come through this coil and through this XAD trap is caught in this first impinger, goes through a series of impingers. These contain water, okay? And then this is the real modification to OTM or method 0010 is we have a second XAD trap at the back end of this thing for any breakthrough, anything that gets past, all of this is captured in this breakthrough XAD trap. Gas goes out through some silica gel to, take out any other moisture, so we're not getting that in our system, in our pumps and all that. Goes through and it's measured. We have a dry gas meter, so all the gas going through here is dry, and we're going to be reporting on a dry standard here. Well, once we get to that point, the recovery on this thing is we're normally with 0010, there's a set of solvents to recover with. In this case, for OTM 45, we're recovering with a mixture of methanol and 5% ammonium hydroxide. So if you notice over here, this comes right out of the OTM 45. This dry gas is right out of the OTM 45 itself. You see there's 7 fractions on this thing: a filter, front half rinse, XAD, back half rinse, condensate, and the impinger rinse. So front half is this first piece here. Ends up that then the back half sample is going to be combined. So we're going to combine this, everything in the back half of the filter and the condenser with the XAD resin, and then we're going to do a rinse on this glassware with the solvent, and those 3 fractions are going to be combined for the second piece of this, or the second fraction. So 7 fractions are collected, but you end up with 4 fractions because you're combining some of these together. Okay. The analytics are liquid chromatography with tandem mass spec. And this is an isotope dilution method. So there are isotopes are added to, isotopically labeled compounds are added to the extracts from these fractions, these 4 fractions. And in the end, when they do the recoveries of these, known amounts of these isotopes are added to the fractions, and in the end, the recoveries, the results are adjusted based on the recoveries of these isotopes dilutions. So there's a lot of performance-based QA/QC in this method, and that's part of it. The XAD resin, there are PFOA and Pfas standards that are also added here to make sure that, number one, they're staying on the resin, we're not losing those, and to demonstrate that the resin is actually able to absorb those compounds. And there's recoveries standards for that, 70 to 130% recovery for that. Some things that are of note, at least from the sampling side for me, is we do media blanks for all the, for the filter, for the resin, for the solvents, for the water, and then we do a blank train. The blank train is basically after we've done one run, or in a number of runs, some of the glassware is set up again, taken to the location, no stack gases pass through it. It's heated just as the other sampling trains are, and then we recover it the same way that the other sampling trains are. So this is going to demonstrate if we've taken clean what was clean glassware, done some testing with it, and then reused it and show that we've captured everything off of that glass with it. Nothing's, in our recovery procedures, there should not be anything coming out on this blank train when we do the analysis. The other part of this is there's a proof blank. So we take unused glassware and just run it through the same thing. We take it to the location, set it up as similar to the blank train, and then recover it again to show that the glassware, the unused glassware, was clean. Let me move on here just a little bit. So that's OTM 45. Semi-volatile PFAS. Semi-volatile meaning that it volatilizes above 100 degrees C. In some of the testing that we did for Chemours, we were looking at either very high concentrations on, say, some inlets to scrubbers or carbon beds or to the oxidizer, looking very high concentrations. And so we couldn't use this methodology because we quickly saturate this XAD, saturate some of the other pieces of this. So and then some of the compounds we were looking at there were highly volatile. They fall in the volatile range. So let me just back up here. So this is the train itself. And this is the glassware, and you can see our probe is entering the stack here. There's a number of thermocouples here where we're controlling the temperature of the probe, controlling the temperature of the filter box, controlling the temperature in the XAD resin water jacket, and this is it. But if you look right here, this coil is horizontal. OTM 45 has the coil vertical. So this is, we had to change this up. This is an older picture, but I wanted to show you what we were doing at Chemours for most of the testing. We had this in the horizontal position. We moved to the vertical with OTM 45. So here's some of our guys kind of in action here. So in this situation, there's potential for HF in these ducts. So they had us in acid suits. This is a Chemours person. This is our guy. We put the probe in. We had a compression fitting on this probe, seal it all down, and then the Chemours people would open up the duct so that we could then push the probe further in to where we need to be for testing. So you can see that here again. In this situation, the glassware is separated from the filter, and we've got a line running over here where it's coming into our glassware. In OTM 45, this line is required to be heated. We weren't heating it when we did this testing. And again, you can see the control box here that's measuring all these temperatures and flow rates and that kind of stuff. And then up here in the upper right is just the same thing, but a vertical traverse where the probe is going down into the stack. So the next method that we used, we have used at some other places as well, was what we're calling a cryogenic train. So in this train, it's not isokinetic. We're using smaller impingers, not the regular midget impingers that some of you might be familiar with. For the compounds that we were looking for, we went with GCMS on the analysis. Okay, you could use the LC tandem MS analysis. In this train, basically a series of impingers. They each contain methanol. This is in a bath, which the bath itself is also methanol. And we basically put dry ice in this impinger train and chill this all down to minus 100 degrees F. So basically when we're pulling the gas through this, we're condensing everything as much as we can get down into these impingers. Thing to notice right here, Teflon impingers, Teflon probe. So, that probably raises a lot of eyebrows. How are we doing sampling for PFAS in Teflon? So we've done a lot of background checks, blank checks, and went through this with the lab, and we're not seeing where PFAS are, coming off of these Teflon impingers. If you look through OTM 45, there are spots in there where they say use Teflon for the frit that supports the filter, use Teflon tape to seal the impingers, that kind of stuff. So, and we've done testing where we've sent rinses of Teflon tape or other Teflon portions to the lab, Teflon impinger rinses to the lab, just to see if we're getting anything off of this, and we're not. So it's kind of hard to envision using Teflon to test for PFAS, but we have. I'll come back to this in a little bit, because this may have other applications for us. Here it is. This is actually at a commercial facility where we use this. A couple things to note here. We put these valves in the jumpers in between the various impingers. We found out the hard way that when you pull impingers out of minus 100 degree methanol and let them sit, if you don't have these valves, the pressure inside these impingers will change quite rapidly, and it'll actually force some of your sample out the end of the tubing coming out of these impingers. So that was an aha moment for us when we started having those happen. Notice here that I set up another impinger out here. Another issue we had was when we pull that gas into these impingers at minus 100 degrees, this first impinger, any moisture in there was freezing up. So we put an impinger outside, just in an ice bath, to chill it, knock out any condensate in this first impinger, and then move on. And these valves just helped us, allowed us to let that thing sit for a while and temperature equilibrate, and then we could go ahead and do the recoveries. So we've learned a good bit on both of these methods over time on how to handle some things with it. Here it is in practice. This is actually at a facility in New Hampshire. The reason that I took this picture was, you see this long piece of Teflon that is attached to our probe. We had to cut that down, move this over so that we weren't using that long piece of Teflon. I took that picture just to show our guys here, but here it is in action, and a series of impingers that are analyzed. In this case, we use GCMS again. So detection limits. That was one of the earlier questions. So OTM 45, they actually have a table 45-11 that gives Instack detection limits and MDL detection limits, and you can take a look at that. The numbers there, 0.05 nanograms to 2.8 nanograms, that's just looking back at some data and coming up with a range per sample. And that varies on which fraction of the train you're looking at. So remember I said there were 4 fractions in OTM 45, so we see different detection limits in different fractions, and it varies per compound. So there's 50 different compounds we're looking at, and these detection limits vary per compound, and then per lab. Each lab has their own way of doing things, and so there are going to be differences in the lab. What all that equates to is, and this is straight from OTM 45, parts per quadrillion in the stack PFAS concentrations. I know that we've seen parts per trillion, and I haven't looked back at the data, but we probably have seen PPQ just in that. I know there were some that were probably point something PPT. For the modified method 18 method, this is the cryogenic method. Not quite as good on the detection limits, but I'm sure the lab has probably drilled these down since I put this slide together. But still equating to part per trillion in the PFAS concentrations in the stack gas. So when I did this, I almost titled this slide, what's the point of this slide? Because the point is not for me to get into any detailed explanation of the methods listed here, the analytics listed here, because I would not be the person to do that. I'm standing on the shallow end of the swimming pool, and I would, about 1 or 2 steps, I'd be in over my head. But Kathy mentioned that EPA has a canister sampling method. I know they've used it at the facility she was discussing, and I think they've used it probably at a facility up in Alaska, Moose Creek, where they were testing the incineration of AFFF. I don't know much about this method, only that you can measure the very highly volatile PFAS and non-polar PFAS with this. The data I saw, they were looking at 4 liters of sample gas in a canister, so a very small sample, and looking for compounds that are not going to be collected on the OTM-45, or possibly not even in that cryogenic train if their boiling points are below minus 100 degrees F. Okay, a couple other sets of analyses here that in the air side, we're not that familiar with. These have been around, I think, on the drinking water side, and people, dealt with this to a point. But total organofluorine, the idea is to measure the total fluorine, somehow separate out the HF, and I don't know if that's been fully explored yet as how to get to separate the HF. One thing that we could do with this, you have a total fluorine number, you measure the HF by some other method, EPA 26 or 26A would, work for that, and then make some assumptions that the rest of it is in some form of either PFAS or, some other fluorinated compounds. So, like I said, I can't go into very much detail on this. I don't know that we've done this on the analytical side for any of our testing. Total oxidizable precursors. So I mentioned before, some of these precursors, some of these fluorotelemers. To measure some of these, you can do this top analysis. Converts polyfluorinated precursor PFAS compounds to measurable forms of PFAS. And then one that, again, very little exposure to on our side, but it's this time of flight non-target analysis. And this is, as it says, liquid chromatography, quadrupole, time of flight spectrometry. It's not quantitative, but you can, with this, you determine the chemical structure to identify compounds that are in the sample. So, these are things on the horizon, and there's been a good bit of talk, at least I'm told, about using that cryogenic train to collect samples, for this TOF analysis or the top analysis. And I don't know what sampling technique would be used for the non-target, but I'm sure that cryogenic would probably fit in there as well. So I just want to let you guys know that there's more to come. I mean, OTM-45 is just the first step in collecting samples for PFAS analysis. There's much more to come on how we're going to do this in the future here. We've tested chemical manufacturing facilities, some coating operations, a sewage sludge incinerator, and a carbon regeneration facility. Picture there's at a site in New Hampshire doing just that. Other sources, Kathy kind of touched on this. There's, it's left to the imagination. I've listed out a few here. One that's come up recently for us is carpet manufacturing. So I'm sure there's just any number of sources that may need some kind of PFAS testing in the future. Like the only thing I note on this picture is for the air dispersion modelers out there. We got one plume that's going straight up in the air, and then another plume that's going crosswind. And this is something I take note of when I'm out there, because I see this quite often where plumes are going in different directions on a site. And so I just thought that was interesting to throw into this. This is we tested different types of air pollution control systems. So at Chemours, the 2-year plan was that they had to put an oxidizer in place to vent a lot of their processes to that was kind of the final solution to destroy these PFAS compounds. And when we did that testing, we were able to show 4 nines for the combination of compounds, 4 nines% removal efficiency or destruction efficiency. But for a lot of compounds, we could see 5 nines. I don't know that we got down to 6 nines, but we definitely saw, met the requirements that they were under, and exceeded those on the destruction removal efficiency percentages. They had a number of scrubbers, carbon beds. This is one of their carbon beds. You can see where the ports there for the inlet testing on this carbon bed. We did one pilot air stripper at another facility, and we've done some incineration as well. And I'm sure there's other pollution control systems. I think, the oxidation is the one that seems to be getting the most attention, but I'm sure there are other mechanisms for this. So what's in the future here? In 2019, EPA issued their PFAS action plan, and that covered, a wide range of things. I'm sure most of you are familiar with this. And some of it was related to stack testing and goals for developing methods and not only stack testing, but ambient and others. One thing to note, EPA Administrator Michael Regan is the new EPA Administrator, and he is from North Carolina. And he's very aware of, the situation in North Carolina. And just a couple months ago, he issued or put forward this EPA Council on PFAS, and his words are one of his top priorities. So, I think there's lots more to come on PFAS, and especially on the air side, just based on his experience from North Carolina. We're going to get actual validation probably of some methods. OTM 45 is not, I don't think, officially validated, but it's another test method which can be used. And there's going to be promulgation of some of these other methodologies and analytics that, I was discussing earlier. Legal action by state regulatory agencies. Kathy touched on some of this. We're just going to keep seeing that, and the regulatory community is going to determine what processes are going to be regulated and what compounds need to be measured, and there will be air emission limits coming. So I predict a lot of lawyers, engineers, chemists, and stack testers will have a future here in PFAS in air. That's it. I wanted to give credit to Billy Anderson at Eurofins Test America. I mean, he really has been kind of the crux of developing the methodologies that we've been using, and we've been putting them into action and implementing those. But as a Test America, Billy and Courtney Atkins have been, highly involved in setting this, and they have the ear of EPA ORD. So they have lots of communication with EPA ORD on these method developments. That's it. I'm going to open it up to questions.
Great. Well, thank you so much. That was very interesting and good information. So a lot of people seem to be keying in on the sampling, actually the materials used. So some people are having a real hard time believing that using Teflon tubing is not adding any any PFAS. So yeah, are there results there? Do you have, how confident are you in that?
So was I, and it raises a bunch of red flags. All I can say is we've done a number of blank trains, rinses, all of that on Teflon. One of the analogies that was made to me was, okay, when we're recovering out of glass, we're not pulling silica out of the glass. I don't know if I like that analogy, but that was one of the analogies that has been put forward to me. Yes. So the bottom line is we have done a lot of rinses of the glass of the Teflon impingers, done blank trains with it, and a lot of times, though, what I will say is we were using these on the inlets to, not always, but on quite a few of them, we're using it on the inlet. So we knew there was going to be high concentrations, and the contribution, if any, was going to be very low. So we weren't as worried about it in those situations. But I mean, I have taken, rinses of Teflon tape, rinses of Teflon tubing, rinses of the impingers, had those analyzed, and we're getting either non-detect or some very low hits from the Teflon. So all I can say is from our own experience, and like I say, in OTM 45, there are components that they are suggesting are Teflon, the Teflon frit behind the filter, other Teflon components, and then Teflon tape to seal it up. So we have seen blank contamination, and we've done everything we can to deal with that. One of the changes that is in OTM 45 is much more rigorous use of solvents in the glassware preparation. But I'm fairly confident that it's very difficult to get some of these PFAS compounds off of Teflon components.
Okay. Any chance you're going to be publishing anything about that? Because that might be helpful just for the community.
Yeah. So I wish that EPA would do that. I mean, Weston, my role is I'm not a researcher. Okay.
Yeah.
While I'm doing PFAS testing, I've got teams out doing, all kinds of other testing. So, we're not a research group, but I would certainly like to see somebody like EPA or one of these other groups, do some of that and put some information forward.
Okay. And then the other piece is using glass. So, I think there's messaging for groundwater sampling not to use glass bottles because some of the PFAS might actually absorb or adsorb to or from the glass. So, I don't know exactly, but so what's the scoop with using glass, particularly at these high temperatures?
Yeah, so all the stack testing methods are written up with this glassware, and that's standard operating procedure for almost all these stack testing methods. The ammonium hydroxide, that 5% ammonium hydroxide in the solvent, is there to pull these compounds off of the glass. So that is something that's known, and we've tried to deal with in this methodology with the addition of the ammonium hydroxide. And I'm not a chemist. I'll let Billy Anderson, if you have questions about that, I'm sure Billy can answer the questions. I throw something his way.
Oh my goodness. All right. So now a bunch more questions have come in that I haven't looked at yet. Let's see. Let's see. What was the reasoning for combining the back half XAD and impingers? How does he handle the combined? How does the lab, sample?
Yeah. So
the combined?
I can't go too far into the laboratory side of things before I'm in over my head, but they do extractions on all 7 fractions, and then those then they combine those extracts for the final analysis. So everything in that front half stays in one portion. Everything in the back half, except for the condensate itself, is combined. And you have the condensate fraction, and the last piece is the XAD at the end of the train. One thing to note about the XAD at the end of the train. So, that's there for breakthrough analysis. So what that means is, is everything being captured in the train prior to that XAD resin at the end. If that result from that final XAD is less than 10%, then the method doesn't even call for you to add that to the actual result. If it's greater than 10%, you add that fraction to the other three fractions in your results. If it's greater than 30%, it says to flag that in your write-up and note that. I think that, and also that third, and that, if I'm correct here, I'll make sure I'm saying this correctly, the 30%, if you're above 30%, that could invalidate your test run on that breakthrough impinger.
Okay. This one can be for both Kathy and Wesley. We're talking about sources of air emissions, like concerns. And people are wondering about like computer chip manufacturing and other sort of high-tech manufacturing, whether PFAS emissions might be a concern, or if you've worked on sites where that it's a concern.
So all I can say is that we will be finding out that answer here coming up. Okay. And just keep in mind, I've got a stack of confidentiality agreements, non-disclosure agreements, so I have to be careful what I put out there. But there will be an answer, at least for one of those facilities.
That will come out publicly, you're saying?
I would say yes at some point.
Okay. Kathy, do you know anything about those kind of sources?
Not specifically. I know that the circuit board industry uses PFAS chemicals to make some of their products, and I've talked to a few, or one at least, some of the stuff that they use. It's in that particular situation, it was a very isolated, small amount of it, not PFOA type of material. But as Wesley said, I'm sure we'll be learning more as time goes on.
Okay, back to the OTM 45 method. Is the second XAD trap the main difference between method 0010 and OTM 45? Is a different solvent, methylene chloride, because a different solvent is used in method 0010?
Yes, so the answer is yes. That's the main difference, is we have that breakthrough XAD trap on the back end of it, and the recovery solvent is methanol and 5% ammonium hydroxide. Okay,
I think I'm getting through these questions, but here's just sort of a more generic one. It's just that the write-up for this method is very long. Is that unusual for air methods, or like it just seems very long?
So yes, it is longer than most methods, and a lot of that is related to the analytics. So there's a lot more specificity in the analytics. But if you look at this compared to maybe method 23 for dioxin-furan, or the semi-volatile method 0010, there's a lot of that in there too. But this is longer than what you would see for most test methods.
Okay. Yeah, we're jumping around here a little bit, but someone is wondering, and I think Kathy had this in one of her slides, about using AFFF. where AFFF has been sprayed and used, is there air emissions and spread that way associated with AFFF use?
So I don't have specific information on that. I've mostly dealt with point sources, not area sources when it comes to PFAS, but one would assume that if someone used foam, that not only did it liquefy and, go into the ground and groundwater, but also that it could bump off property or cause the dispersion that way, but I don't have any specific information.
Okay. Okay, here's another one, which I don't know a lot about air testing, so I'm not sure. Have you used the modified test method 18 on PFAS in practice? I guess that could be either one of you.
Did you say on PFAS in what? In practice, you said?
Yeah, have you actually used it?
Oh, yeah.
Excuse me. At
Yeah. So we use that. We use that method quite a bit at Chemours, and we've used it at 2 facilities outside of that. And we've used it a lot on the inlet ducts, but we've also used it on some outlet ducts as well. Outlet to control devices.
Okay. Let's see. Get that out of the way here. Let's see. I think there might be one more. Okay. So I guess this is a good place to end, and we're almost at 3 o'clock. So someone's just pointing out that that it really would be good if EPA would step up and do some of these studies and provide the information and make it public that we're doing these webinars to sort of share information, and some of it's generated through the private sector, but it really is sort of the government's job to to step up. So hopefully EPA will be doing quite a bit, as Wes sort of indicated. There's new leadership there that's very aware of PFAS, so and the air emission piece of it. So in the beginning, was not able to show folks the NMOA website and where the presentations will be posted. I will also send you an email when the presentations are posted, but I think the NMOA website is working now. Here it is, so it will take a little while, a week or so, before the presentations are posted, but you go to the Wayside Cleanup, you pick Wayside Cleanup, then you come over to Events, and then here's things that are still in the future. We have a split personality for this one today. It's sort of a today event, but it's also a past event. And then you just keep scrolling down. The most recent things are at the top, and then go back in time. We've done quite a bit of webinars. We did 12 altogether on PFAS this spring. We've also done webinars on non-PFAS topics. We've done some webinars that maybe weren't widely advertised to the public, like this case study in Maine. However, the slides are available, so the PDFs of the slides are available I'll just pick the wastewater one. Everybody's the 2 presentations, they're described, and the PDFs are linked on here. So we have a wealth of information on the NMOA website going back in time. We've done lots of PFAS webinars. We've also did webinars on PCBs and vapor intrusion and some other topics as well. So I encourage you to check out the NMOA website. Presentations, PDFs will be posted at some point after this webinar, and I will send a link when they are ready. Anything else? I think we're good, and it is just about 3, so this is perfect. Thank you so much to both Wes and Kathy for their really informative presentations, and just all the the work they've been doing and their willingness to share it with us. So thank you again, and everybody enjoy the rest of your day. Bye-bye.